Fine. So I do believe everyone is present. Now let's start our class. So few of you might be absent tomorrow, right? So for them, I want to just let them know that we have completed few questions. We have completed few questions. So we were doing the same chapter measurement. In the measurement, we have discussed about the SI prefixes, the physical quantities, and there are two types of physical quantities. One is fundamental and one is derived. And other than these two, there is one more supplementary quantities, right? And there are two types of supplementary quantities. And there are 7 types of fundamental quantities. These all things we have studied earlier, right? Right? Okay, and after doing all these things, we were learning about how to do the unit conversions. And in learning in the same process, while understanding the unit conversions, we have also discussed some questions based on the same. So this FPS, CGS, these all things we have already discussed. The SI system. SI system stands for, in English it is International System of Units, but in French it is called a Système International. These are the 7 fundamental quantities. As I told you, physical quantities are classified into 2 types. One is fundamental and one is derived. So these are the 7 fundamental quantities. And derived quantity means any physical quantities whose formula is known and it can be derived by using the fundamental quantities. The quantities which depends on fundamental quantities, those are called as derived quantities. Sir, the class, no. Today class is only 1, not 2 hours. Don't worry. Right? Moving ahead. So we have done this physical quantities, yeah, right? Same fundamental, derived. So fundamental quantities we have discussed already. The quantities which are independent of one another are called fundamental quantities. And with derived quantities, as I told you, which depends on the fundamental quantities. Simple definition you can learn. Now next, SI prefixes. We had discussed about the SI prefixes, right? And from past 3-4 days, we are doing the same thing. This SI prefixes only and numericals based on these SI prefixes. So SI prefixes, you can see, this is the border line. Here is the border line. Here is the border line, right? So, sorry, not there, below that. Above this, the 10 to the powers are in positive, and below this, the 10 to the powers are in negative. So, simple way to learn these things, you can learn it by deca, hecto, kilo, mega, giga, tera, peta, exa. And all the 10 to the powers, they are increasing with the power plus 3. Arno, you are asking something? Sir, once you scroll down. What, Arno, you are asking? What is your question? Yes or no? What is your doubt? Scroll down, sir. Arey, Arno, only one period, yaar. Don't worry, yaar. I'll not take much time today. Don't worry. Right. Similarly, when we are moving down, so we can learn deci, centi, milli, right? Micro, nano, pico, femto, atto, right? So these all things are the SI prefixes which we were using in solving the problems, unit conversion. We had learned about unit conversions, right? So Fermi, we know 1 Fermi is equal to 10 to the power minus 15, 1 angstrom is equal to 10 to the power minus 10. These units we have to remember for our easiness when we will solve the numericals of physics. And moreover, when you are upgrading every year, right? When you are academically, you are upgrading every year. So these units is going to help you a lot. If you are learning today, will be very helpful in your grade 9 and grade 11, right? And after that also, during your graduation time, if you are going to be somewhere in research part, there also you will be using all these units, right? So these units are very much important. So better to learn it now itself. Light year, to measure the long distances, we use this unit light year. If someone wants to become astronaut, right, or someone wants to join astronomy in research, so these units they are going to use. These are day-to-day life, quintal, metric ton, these units too we are using. This is about time, units of time, year, lunar month, solar day, we already know. Right? Next. We had also discussed these distances, same thing. Now worksheet, we have completed question number 1, 2, all this, right? After doing the questions, we reached till question number 9. Till here we have completed. Till here we had completed yesterday. Now next question. Next question. I guess everyone knows the answer of the next question, right? Ishika is asking, sir, can you explain again how to convert units? Okay, Ishika, sure. On Saturday again we will have this doubt class, right? On Saturday I teach you how to convert it. Please be present on Saturday, right, Ishika? In the further question, just you can see how to convert. Now next question, please be ready. What is the matrix prefix for 10 to the power minus 3? Matrix prefix for 10 to the power minus 3. Okay, Sad, okay, got it. Dipya saying namaste, sir. Namaste, Dipya. Samiksha, I can see your chat, Samiksha. Yeah, so has only one class. Okay, maximum is saying option C. It is asking what is the matrix prefix for 10 to the power minus 3. Matrix prefix, read the statement, read the word, every word is important. Matrix prefix for 10 to the power minus 3 it is asking. Right? So we know 10 to the power 3 means what? Yeah, option C. We know 10 to the power minus 3 is milli. Right? 10 to the power minus 3 is milli. So the option C is the absolute answer for this question. Yeah, option C. Right? Now we will move ahead on our concepts. Suhas is asking, sir, should we draw this worksheet? Actually, you already have the PDF, Suhas. Everyone is having that PDF. It has been shared on your parent's number, right? You can download that PDF and take a printout, or else if you are having tab or laptop, you can use those things. Ritvik, what you are asking? I can see your chat, Ritvik, but better to chat in my chat box now. You can on my name, Akhilesh, just click there. And you will have a chat box. You can come in my personal chat box. Ritvik, sir, one scroll down. Sir, what is your question, Ritvik? Yes, Suchitra will start today. That is scalar vector. Ritvik, say, what's the question? No problem. No problem is your question. Okay, fine. Yeah, Dakshit, what happened? Yeah, I can see your chat, Kitan, but it's better to write here in the chat box, in my personal chat box. See, 700, 800 comments are receiving, so it's very hard to read everyone's comment. Suchitra, I think, didn't get the worksheet. Actually, worksheet, the link has been shared. Suchitra once inquired with your parents, right? They might have received the link from this resonance site. In the link, you will have all the worksheets, all these PDFs, what I am displaying over here. Now it's there. If not, then once inquire with the school principal. Nandan is asking, sir, what do you mean by metric prefix? Metric prefix means same, yaar. Like SI prefix we had studied now. SI prefix we had studied, right? So metric we are using for this term, and prefix means any number which is added before the unit. For example, meter is there or gram is there, right? So if this is meter, if before meter I'll add just one thing, that is C, it will become centimeter. It will become centimeter, right? So centi means we should know that the centi is equal to 10 to the power minus 2. So this is the metric prefix for this unit, meter, right? Suppose gram is there. If I'll add a prefix k, so k means k stands for kilo. K stands for kilo, and kilo is equal to 10 to the power 3. So this is metric prefix for this unit gram, right? Okay, fine. Moving ahead to the next. So in measurement, we had discussed about this physical quantities, right? We discussed about SI prefixes. We know how to convert units. Those who don't know, for them again we'll discuss on Saturday, right? Akshara is asking, what's your name, sir? Again, Mr. India. Mr. India is my name, Akshara. Arey Akhilesh, you'll get my name with Akhilesh. It's written there, Akhilesh, right? Okay, so we are going to start the new topic, that is scalar and vector quantities, right? Now we'll understand what is the meaning of scalar and vector. Fine. So earlier we had discussed about physical quantities. There are two types. One is fundamental, one is derived. Now, scalar and vector, we are defining those physical quantities on the basis of their magnitude and direction, right? On the basis of magnitude and direction, these physical quantities are also classified into scalar and vector. Clear? Clear? On the basis of their magnitude and direction. When I am saying magnitude, so some of you having doubts on what is the meaning of magnitude. If you are having doubts what is the meaning of magnitude, then remember, magnitude means we are talking about numerical value. Magnitude means it is referring to numerical value, any number. Any number. For example, when you are saying, when you are going to that vegetable shop, you are buying some vegetables like, or let's say tomato. So you are saying 1 kg tomato. So 1 is the magnitude, kg is the unit. Clear? If you are going to buy rice, so you are saying 5 kg of rice. So in 5 kg, 5 is the magnitude and kg is the unit, right? When you are saying 30 kg, 30 is the unit, 30 is the magnitude and kg is the unit. Clear? Clear? That number is numerical value. This numerical value is called as magnitude, right? So on the basis of magnitude and direction, physical quantities are further classified into two types, that is scalar quantity and vector quantity. Now coming on the main part, sir, what is the meaning of scalar quantity? Who is saying no? Anvi saying no. What happened, Anvi? Anvi? Yes. Yes, Akshara. Correct. Yeah, please. Good morning. Ask Chakri. Thada Kamla is asking, sir, I have a doubt. Yes, ask. Vishyan, you are not liking this class. That is why asking what is the next class. Jacker. Thank you, Jacker. Jacker is saying, sir, come to Suchitra branch. Okay, fine. Yeah, you have to write. You have to write. Don't worry. I'll let you when you have to write. Right? First listen to me. Then I'll let you know how to write and what are the things which you have to write. So those who did not understand, someone is commenting, sir, I did not understand. So listen once again. I guess it's okay. Listen once again. Earlier we had discussed physical quantities are of two types. One is fundamental and another is derived. Right? We had discussed earlier. So now again we are discussing these physical quantities are further classified. Actually there are two types of physical quantity, fundamental and derived only. If someone asks you how many physical quantities are there, your answer should be two types. And what are they? Fundamental and derived. right? Now again, if someone asks you what is fundamental quantity on the basis of their magnitude and direction, on the basis of their magnitude and direction, then your answer should be scalar quantity and vector quantity, right? Now coming again on scalar quantities, and those who don't know magnitude, meaning of magnitude, so I have written on the board, you can note down this at somewhere in a note, writing a note somewhere at the corner of the notebook, you write a note and there you should note down this part, meaning of magnitude. Magnitude means numerical value. Magnitude means numerical value. Numbers, the numbers which are there present in before any unit, those are called as magnitude. So the 5 kg, 5 is the magnitude. 10 kg, 10 is the magnitude. 18 kg, 18 is the magnitude, right? I hope everyone understood now. Now coming on scalar quantities. What is scalar quantities? So very simple to understand. The physical quantities which have only magnitude, right? Which have only magnitude but no direction are called as scalar quantity. For example, whenever you are going to buy any vegetable, sir, always you take the example of vegetable. Yeah, because it's very simple. It's very simple to understand. It's common. We can correlate it with our day-to-day life. That is why I used to take the example of vegetable every time. Everyone knows that, right? So when we are going to buy vegetable, if you say, listen, if you say, sir, so not sir, vegetable wale bhaiya, just give me 5 kg of potato towards east. Have you ever told that kya? Did you have ever mentioned to vegetable wale bhaiya ki bhaiya give me 2 kg of potato towards east or towards north, means adding the direction? Never, no? We never did that, right? We never did that. We always used to just say, just give me 2 kg of potato or 3 kg of potato, right? Right? We never mentioned the direction. So that is the meaning ki that particular quantity you are mentioning. What you are mentioning? 2 kg. What you are mentioning in that? Mass. What you are mentioning? Mass. You are telling to that vegetable bhaiya ki to give you 2 kg of potato. So 2 kg is the mass of the potato, right? You are mentioning the mass. So mass is a scalar quantity. In that you are not mentioning the direction, right now? Sayoni is saying, sir, I didn't understand. Okay, Sayoni, for you once again. So Sayoni, just let me know, did you have ever visited to vegetable shop? Yes, Sayoni? Okay. If you have visited, have you ever asked to that vegetable wale bhaiya, ki bhaiya just give me 5 kg of potato towards north or towards right? Or no, I'll reply, wait or no. No, na? Means we are not mentioning the direction. Towards north, towards right, towards south, it means we are mentioning the direction, right? So when we are telling to that vegetable bhaiya, we are only mentioning the magnitude. What we are mentioning? The magnitude. Numerical value only. 5 kg. 5 is the magnitude and along with that unit. Right? So we are mentioning the only numerical value and unit. This magnitude. So when we are mentioning this magnitude and what we are asking? 5 kg of potato. So 5 kg means we are talking about the mass of the potato. We are talking about the mass of the potato. Right? Right? Understood? So mass is a scalar quantity because it does not have direction. Similarly, time. If someone asks you time at your home, right? Suppose your mom asks, "Beta, what is the time?" So did you ever told, "Mom, it's 8:52 towards north or above north"? Have you ever told that? No, na? You didn't told, na? So it means when we are not mentioning the direction of any physical quantity, time is a physical quantity. Time is a physical quantity. And in physical quantity, which part it is? Fundamental. Do you remember there are 7 types of fundamental quantities? So time is a fundamental physical quantity, right? So when someone asks you, you are just only telling the magnitude of time. Okay, it is 9:50, 8:50, 9:10, 10:12. You are not mentioning the direction along with that. Okay, it is 8:50 towards east. Have you ever told that? Or have you ever heard someone telling like this? This is 8:50 towards east. No, na? No one mentions like that the time. So time is a physical quantity and as well as this physical quantity is classified into scalar quantity. So the quantities, the physical quantities which do not have direction but only possess magnitude, only have magnitude, that is called as scalar quantity. Sayuni is asking, sir, in the clock the hands move around, but they does not have specific direction, Sayuni, right? When I am saying the direction, they does not have specific direction, and we never mentions direction along with time. So you are watching that analog clock, right? What about digital clock? In digital clock, so nothing runs, no? Nothing needle or nothing something, right? What about that, Sayuni? Understood? Okay. So what you have to write for physical quantity? First statement you will write on the basis of magnitude and direction, right? On the basis of magnitude and direction, physical quantities are classified as, okay, I'll write on the board over here. In your notes, your topic will be scalar and vector quantity. The topic which you will write is scalar and vector quantity, right? Scalar and vector quantity. Then next you will write on the basis of magnitude and direction. On the basis of magnitude and direction, physical quantities are classified into two categories. You will not write this which, right? From here, on the basis of magnitude and direction, listen, see on the screen, what do you write? On the basis of magnitude and direction, physical quantities are classified into, or broadly you can add or you will not add, that also okay, no issues. Physical quantities are classified into two categories. First one is scalar, second one is vector. Write fast and let me know. Write fast and let me know. Arno, class will be till 9:20. Why you are so worried about a class, Arno? You are asking, keep on asking the same question. Do you have any other plan today? Good, very good. Varnika has completed, Vikram has completed, nice. Avani has completed. Srishant Ali is saying, sir, can you come to Hyderabad Unasthilipuram branch? Yeah, one day surely I'll visit, don't worry. Sri Charan done, okay. Done, very good. Aditya, I guess there is a network issue at your home. Just once please cross check with the connections, na? Because for others the screen is visible. Dear Jayant Krishna, even though you are having the worksheet, along with that you are having the notebook also, right? So don't excuse, sir, I have a worksheet, please I should not write. Don't give me that excuse. You have to write in your notebook. Very good, Mayim has also done. Very good. Maximum of you have completed here. Wow. Nice. Great. Sayoni, you have to write. Yeah, you have to write, Sayoni. First, you have to write about scalar. So, first statement what you have to do, on the basis of magnitude and direction, physical quantities are classified into two categories, scalar and vector. Those who don't know the meaning of magnitude, write a note at somewhere in the corner of the notebook. Someone is asking, sir, what is your branch? Resonance. Resonance is my branch. Kaustubh, sir, in which group should I chat? Arey, there is no other any other group. Yaar, you should chat on my name. Click on my name. You can chat there. Sharanya, which branch are you, sir? Resonance branch, Sharanya. Vidish, sir, are you coming to any branches? Vishneshwar is asking, sir, which branch you work for? Arey, same question you are asking. I work for a resonance branch. Resonance is my branch. Not any specific place. In Hyderabad only. Don't worry. Arey, Kaustubh, I'm seeing both here. You just chat there. No issues. I'm seeing here also. Kaushik, yes, I can say your name. Don't worry. Yeah, I can see your chat, Akshara. Sanvi, come to Madhapur branch. Okay, fine. Okay, I hope you all have completed. Fine. We will enjoy. No issues. So we understood about the physical quantities, and on the basis of magnitude and direction, they are classified into two types. One is scalar and another is vector. Now you have written there are two types of physical quantities, but on the basis of magnitude and direction, right? Now stop commenting, everyone. I need your concentration over here in the class, right? Everyone, please stop commenting. Please stop commenting. I need your concentration. Don't let your mind to be distracted because of commenting, right? Don't engage in chat box. Come out of the chat box. Listen to me. No one should chat now. Stop everything. Concentrate in the class. Akanksha, concentrate in the class, Akanksha. Right? Stop. Still I am receiving chats. Stop commenting, everyone. Stop commenting. I don't want to see a single comment now. Right. Please come back to the class. Don't comment. Don't let your energy to be distracted. Scalar quantity. We are going to discuss about scalar quantity. So I had told you earlier also the physical quantities which have only magnitude but no direction. They are called as scalar quantity. Examples I have taken that mass, you remember? Buying the vegetable from vegetable wale bhaiya, remember? So mass is a scalar quantity because we are not mentioning the direction in that. Similarly for time, we are not mentioning direction in that. We are only just saying the magnitude of the time. So this is a scalar quantity. Another example can be the distance. When we are measuring the distance, we never measure the distance in a particular direction. We never mention the particular direction, right? Only we say, if someone asks you, your school is, now listen, very important now, very important. In this example, you will understand the difference between scalar and vector as well. Listen, listen, listen. I want you to listen. Stop commenting. Now example, if someone asks you, imagine a situation, if someone asks you, how far away is your school from your home? Then your answer might be, sir, 10 kilometers, sir, 20 kilometers, sir, 15 kilometers, sir, 2 kilometers, right? When you are answering only the magnitude part, sir, 10 kilometers, sir, 20 kilometers, sir, 15 kilometers, right? You are mentioning only the magnitude. You are answering only mentioning the magnitude. 10 kilometer, 15 kilometer, 20 kilometer, these all things are magnitude only, right? 1 kilometer, these all things are magnitude only. But the twist is here. But if you are answering like, sir, my school is 10 kilometer away from my home towards north, or you are answering, sir, my school is 1 kilometer away from my home towards east. So in this answer, you are also mentioning the direction. You are mentioning the direction now, right? You are mentioning the direction. So as soon as you mention the direction along with the magnitude, that particular physical quantity will become the vector quantity. But For a physical quantity to be a vector, there is one more condition. In next topic, we'll understand. First, understand scalar quantity. So physical quantities which do not, very simple, which no magnitude, only direction. Short trick. For scalar, write the short trick to understand which quantity will be scalar quantity. So for scalar, write the short trick. Only magnitude and no direction. Remember this line. Then you can define by yourself also. Only magnitude and no direction. This is short trick to remember scalar quantity. Only magnitude and no direction. Now the before words, after words you can add by yourself, right? Now if you want to define scalar quantity, if you do remember only magnitude and no direction, then what you can say? The physical quantities which have only magnitude and no direction are called as scalar quantity. And when someone asks you example, then example is very simple. Vegetable shop, है ना? 2 kg means 2 kg is mass of the potato. Time is a scalar quantity. Distance is a scalar quantity, right? Now note down fast this line. What you will note? This line. You will write the topic scalar quantity. What you will write? Scalar quantity. And you will write this line. The physical quantity which have magnitude and no direction are called scalar quantity. After that, you will write this example: mass, time, temperature, distance, etc. Right? These two lines, please note down fast. Note down fast and let me know. Shaurya will play IPL. Shaurya, wait now. Okay, fine. So we'll proceed with our class because we have to play IPL. Now you are very much eager to play IPL. So for playing IPL, I need you all to sit very concentrately and understand the concepts properly so that we'll enjoy while playing IPL. Come back. When you have written these two lines and you have also written this short trick, right? You have also written this short trick, hai na? The short trick also you have written. Now next line which you will write, that these scalar quantities, they are added, subtracted, divided or multiplied by using the only ordinary rules or laws of algebra, right? Now if you are having the doubt, sir, what is algebra? So simple addition and subtraction here. 5 plus 5 is equal to 10. 10 minus 5 is equal to 5, right? This simple subtraction addition which you are doing, multiplication we are doing, that is called as algebra. Yes, Ananya? Right? Great. Write this line also. This line in a point, next line, next point. Make a point and write. Scalar can be added, subtracted, multiplied or divided by using the rules of ordinary algebra. Write this line fast. Very good, very good. Shabash. Very good, very good. Hey hero, who is typing IPL so bhai, so long? Dear Shaurya, maximum of the students do not know about scalar and vector, so because of them we have to hold IPL for today. Right, Gopi Krishna, correct. You know the methods of ordinary algebra. I can see your chat, Kaushik. Okay, Vidit, I'll once confirm. Sunnism Pet branch also. They didn't receive that. Write the name Vidit. This Nizampet branch, Vidit, did not receive that. Yeah, I hope it's completed. Now, moving ahead on our vector. What is vector? We'll understand what is vector. So, everyone understood the meaning of ordinary algebra. Everyone understood the meaning this, na? Everyone understood? Fine. Sri is asking, sir, where can we find PDF of notes? It has been shared on your parent's mobile number. This PDF notes has been shared on your parent's mobile number. It's not like it's a PDF which has been shared. It's a link. Link has been shared from Resonance site, right? Once inquire with your parents, you will have all this PDF what we are studying and every day. Moving ahead. So next is we are going to discuss about vectors, right? We'll understand what is the meaning of vector. Scalar we understood. The physical quantities which do not have direction but only have magnitude, right? Those are called as scalar quantities. Now when it comes to vector, so in vector the short trick can be which have both magnitude as well as direction. For understanding vector, just short trick. Vector quantity, short trick, have both. Earlier you have written only magnitude and no direction. Here you will write both magnitude as well as direction, right? The short trick to remember the vector quantity which have both magnitude as well as direction. Now listen, don't keep on writing along with me. I need you to sit concentrately and listen to the class. If you listen properly, I'll give you time to write. If you listen properly, automatically this data will be saved in your brain, right? So it is very much important to understand the concepts. Then you can go ahead for writing. Now listen. So we understood vector quantities means the quantities which have both magnitude as well as direction. But one more condition is there, means it follows the law of vector algebra, or you can say vector addition or subtraction. So if you are having doubts, sir, what is vector algebra? Then my dear students, you will learn about vector algebra in grade 11 or in 9th. So have patience till then, right? Because if I teach you vector algebra, first of all, it will take time. Second of all, for you, it might be a bit difficult. Not very much. It's not like any one of you cannot understand, but some of you will find it a bit difficult, right? So we'll move ahead. We'll see based on the time. We'll understand. First, understand the definition of vector quantity. How to define vector quantity? If someone asks you, what is vector quantity? So your answer should be any physical quantity which have both what? Magnitude as well as direction. And another condition you will apply and also follows the law of vector algebra. Those quantities are called as vector quantities. Now, for example, displacement. If anyone does not know, sir, what is displacement? So you understand distance? You understand distance now? So the shortest distance from one point to another, from one place to another, that is called as displacement, right? We'll understand that distance and displacement in our further topics also. So no worries for that. Just listen. Displacement means, just understand in very simple way, it is the shortest distance from one point to another point, initial position to final position. That is the meaning of displacement, shortest distance. Sir, what is the meaning of shortest distance? So for example, explaining displacement, listen. Displacement. Suppose here is point A, right? Or you can understand this point A, here is your home. From here is somewhere point B, where this is your school. So for traveling to school from your home, the path which you follow is something like that, the road. You step out at 2 kilometers, right? Then going here at 3 kilometers, then taking right turn, right? 4 kilometers, for example. then again taking 1 kilometer, then again moving here 2 kilometer, then again taking 1 kilometer, then you are reaching to your school. For example, this is the road which you follow to reach to school every day. This is the road which you follow to reach the school every day. Listen, I am teaching you distance and displacement this time also. So in the next class when we will meet, further topics we are having distance and displacement. I'll teach you about that again in detail. We will solve more numericals on that. Just in a short form explaining to understand the meaning of displacement. This is the distance, the total path you are covering to reach to school. This is the displacement. Sorry, distance. If someone asks you what is displacement, so when I am saying the shortest distance from the initial and final position of a moving body, shortest distance from initial and final position. So this is the initial position, right? This is the initial position. Here is the final position. Here is the final position. Shortest distance means the straight line which is joining the initial and final position. This will be the shortest distance. A straight line which is joining the initial and final position. This is the shortest distance. And this shortest distance is called displacement. This shortest distance is called displacement, right? Clear? Another example. Suppose on a circular track someone is running. Someone is running on a circular track, right? So when someone is running on a circular track, it started its journey from point A. It started its journey from point A, right? So and after starting from A, the body stops somewhere here at point C, right? The person who started his journey from point A, after covering this much path, it stops here at point C. Now if someone asks you what is the distance, so you can see this total path covered by the body, this is distance. This total path covered by the body is distance on the circumference of the circle. But if someone asks what is the displacement in this case, so we know displacement is the shortest distance between initial and final position. So what is the initial position? Point A is the initial position. What is the final position? Point C is the final position, right? Now in this initial and final position, what can be the shortest distance? The straight line joining the initial and final position, right? The straight line joining the initial and final position. This will be the shortest distance, and this is called as displacement. Clear to everyone? Clear to everyone? Yeah. Clear now? Displacement is clear? Very good. Very good. It's clear. Right. Thank you. Clear. Okay. So, for vector quantity, you will write the definition. The physical quantities which have magnitude as well as direction and also follows laws of vector algebra are called vector quantities. And example you will write displacement, velocity, acceleration, force. Right? Till here you will write fast. Write fast and let me know. Javir is saying time up. Oh, Javir, you want to exit the class, right? Thank you for notifying, Javir. Nishi is saying time up. So you are not liking the class, hai na? You want to me, sir, please move fast. I want to attend that next class. Thank you, Neet. Yeah. Okay, fine. I know, time is up. Write and let me know. Good, Bhavesh. Yeah, I'll give you a break. Don't worry, Pawan. Rohit Sharma. Arey, today we are not playing IPL. Right, fine. Time is up. I know, time is up. Note down and let me know. Just thumbs up. If you have completed, thumbs up. Done. Very good. Those are completed. Yes, Krishna, I can see. Krishna Sanvi, I can see your chat. Sri Charan, time up. Okay, Sri Charan, I know. V1 is saying, sir, we want freedom. Arey, V1, did I have bounded you here, V1? You are saying we want freedom. You are free, V1. Those who have completed, that's all for today. I know you want break, right? Those who have completed, that's all for today. Thank you. Bye bye. See you again in the next class. Come again after revising all these things. In the next class, we will play IPL. That is for sure. Thank you. Thank you, Sri.
So yesterday we stopped here, right? We stopped here. So element, what element means? I said two terms. If we have only one type of atom, like oxygen, both the atoms are oxygen. Nitrogen, both the atoms are N nitrogen. So this will be called as element. Okay. So if you consider iron, only Fe, same element, gold element. Okay, all will be element. So as per periodic table, till date we have 118 elements. Till now we have 118 elements. Okay, so this is a thing. So let's move to the next slide. So this is point B. First point, this one, representation of element. So short form means symbols. So whatever I am writing here, O2, N2, Fe, so these are all symbols, right? So you have completed up to here. So this is the new thing. Second point, just write this. After that, I am going to discuss all of this. Okay, I am audible. Okay. Now just everyone just write this one table. So how many types of elements we have? How many types of elements we have? Metals, non-metals, metalloid and noble gas. Total 4 classified things we have: metals, non-metals, metalloid and noble gases. Okay. Now I'll give some examples so that you can easily correlate with this. Means what these are means. See, few properties, based on properties we are classifying this. If I ask you metal, can you give me some examples of metal? Yes, you can say, sir, iron, gold, okay, tin, okay, these are all metal. Why these are all metal? Because they are having metallic property. Now what are metallic properties? Like they will be very good conductor of electricity, thermal conductivity will be there, some metallic sound will be there. If you have one metal and if you just try to heat it, some metallic sound will be there, and if you rub two metals, you will hear some, that sound frequency. Okay, that metallic sound that will be there. Okay, metal always try to lose electron. So we will study in detail. So metals means, just remember, they have metallic properties like metallic sound. They will try to lose electron. Okay, that shiny nature will be there. Shiny nature will be there. Correct? These are all metal. Now, if I ask you non-metal, shiny nature will not be there. Yes, wood, plastic, very good. Achha, it is not clear. Wood, plastic, then carbon, you can consider carbon as coal, right? That is there. So non-metal. So you will not get any metallic sound. If you rub to non-metal, you may not get that characteristic sound. Okay, and also that bright nature will not be there. That gold, if you see that pure gold or iron, and if light falls on that, reflection will be coming. But non-metal, almost no reflection. Achha, metalloid. Metalloid is very important. Metalloid is having both the properties. Some properties will be like metals, some properties will be like non-metal. So metalloid means these are the elements. So after some time we will discuss in details. 7 or 8 elements we have. So these elements, they are having properties of both of these, metal and non-metal. Okay, some properties will be like metal, some properties will be like non-metal. And here last one is noble gas. Noble gas is noble from the name itself. It is, special type of gases. Inert gas, there is other name, inert gas, rare gas. Okay, so this type of names we have, inert gas, rare gas. The ultimate thing is, noble gases, they don't usually react with other things. Noble gases, they generally don't react with other things. What does it mean? For example, if we helium is there, right? Let's say helium. Okay, helium gas balloon is there. Helium, and we have another gas balloon. Let's consider SO2, sulfur dioxide, SO2. Two gas, balloons we have. If we inhale, if we inhale SO2, then we will face serious damage. We will get our body, our health will be damaged. We will face lot of problems. Okay, in this case. But if you inhale helium gas, there is no problem. There will be no problem. Why? Whenever we inhale SO2 gas, then that SO2 gas will go to the lungs and it will start reacting with our organs. Okay, so it will react with our organs and it is a poisonous gas, so our body condition will be deteriorated. Okay, our health will be lost in that case. But helium, it is not reactive. If we inhale, it will not interact with our organs. Okay, so there will be no problem in that. So that's why helium inert gas. This is the easiest way to understand. Inert gas or noble gas means it will not react with other thing, and normal gases means they will react with other things. That is the general idea. Okay. Sricharan, I think now it is clear, right? No, mercury is a metal. Mercury is a metal. Noble gas, I have written this thing. Noble gases, other alternative name is inert gas, rare gas, like this. Okay. Acha, writing part done. Deteriorated means our condition, our body condition will be very bad. Means within half an hour, I'll be in hospital. Doctor will be treating my body. So that's the meaning of deterioration. Means condition is getting worse. Okay, our body will becoming very body condition will becoming worst. Yes, so all the things we will discuss one by one. So this writing part is done. Only this, nothing is there, only this few things. See, mercury is the only metal which is available in liquid form. Mercury is the only metal which is available in its its liquid form. Okay, this is the exception, we can say, mercury. So writing part done. Just let me know writing part is done or not. Okay, very good. So here we have this metals. Some definitions we have. A metal is a solid. It is generally metal is a solid, typically shiny. So solid. So underline this: solid, shiny material, conduct electricity and heat. Okay. Examples: iron, aluminium, copper, gold. Within bracket, right? Except mercury, Ag. Mercury is a liquid. It is a liquid. Just within bracket, right? Mercury exception, just I'm writing exception, only it is a liquid, but other properties will be there. Okay, mercury is liquid. One exception is there, mercury is liquid. Acha, now along with this, you have to write the symbol of elements. Iron, just write Fe within bracket. Aluminium within bracket, write Al. Copper, Cu. Gold, Au. Okay, just write this. Within bracket, always write symbol. If gold is melted, can we classify it to metal? See, if we have not only gold, iron, right? Whenever we produce some, product like a hammer or something, first we have to melt those metals, right? Now, based on that, those melted form, we will give lot of different shape, right? Point. This is whatever we say. These properties, these are all at normal condition. At normal condition means at room temperature. Now, you just tell me, at your, in your room, so many metals are there, right? All the metals except graphite, except mercury, all are solid. Check. If you are considering melted gold or melted, iron, those are not at normal temperature. You have to supply a lot of temperature, 1000 degrees centigrade temperature, then only 500, more than 500 or 600 degrees centigrade temperature, at very high temperature, that liquid form you will get. So we are not considering that. Whatever properties we are saying, these are all at room temperature. Room temperature. Okay? Always have to think in that way. Achha, now non-metal are elements found on the upper right side of the periodic table that lacks the characteristics of metallic property. So what does it mean? Lack characteristics of metallic property or characteristics of metallic property. What does it mean? So normally metal is solid, but non-metal, it can be solid, it can be liquid, it can be gas. All three. Okay, it can be solid, it can be liquid, it can be gas. All three. SLG. Okay, so all solid, liquid, gaseous form we can get here. Next, shiny material. There we wrote shiny material. Here we will not get any shiny material, shiny property. Next, conduct electricity. Now here normally non-metals do not conduct electricity. Here also one exception we have. What is that? Graphite. So graphite, it conducts electricity. Okay, it is a good conductor. So you can write this thing. See, that's why I said exception. Mercury is liquid. See, for example, you just tell me. I'll give one example. अरे ये कौन है भाई? Name. Ayush, no need to write this many times, because if you are writing this in this way, you are blocking others' messages also. I am answering now. One time or two times if you write, that's fine. Two times, maximum 3 times if you write, that is fine. But see, more than 30-40 times I think you have written. See, I am answering that. Just try to understand. For example, you are studying physics, chemistry, math. Okay? Physics, chemistry, math. All 3 subjects you are all three subjects you are learning. In chemistry, let's say you are getting 90%. Okay, correct? In math, let's say you are getting 80%. But let's say in physics you are getting 30%. Now you tell me, you are good student or bad student? Other two subjects, you are getting very high marks. Let's consider physics and math, you are getting more than 90%, but chemistry only 30%. What do you mean by that? I'll say you are good student, there is some problem with that particular subject, correct? You are good student, very good student, that's why other subjects there you are getting nice score, but in one subject you are getting very low score, so that's mean that is the exception. Maybe that question paper was too tough, that's why you didn't score. So that's why similar analogy we have to use. Properties, based on properties we are classifying metal, non-metal, right? Now if I consider physical state, conductance, electrical conductance or thermal conductance, then expansion, that one, okay, compression, that part, so many things, metallic sound, okay, so many properties we have. If we compare all of that, this mercury, it is showing all other property. It is a good conductor of heat, electricity, okay, that shiny nature is there, all of those metallic property except this, except physical state. Normally metals are solid, but it is liquid. So can we say only based on this, can you say it is not a metal? No, right? Only one problem is there, that is physical state, but all other properties are similar to metals. So that's why mercury will be classified as metal. Okay, just we have to think in this way. Correct? So see the non-metal. Here also we have one exception. Normally non-metals means which are not metals. What metallic properties or metallic characteristics we have, metal characteristics we have, if something is not following that will be non-metal. Like so many examples we have: sulfur, phosphorus, carbon, hydrogen, fluorine, oxygen, nitrogen, carbon dioxide, all of these, right? Non-metal. Achha, now if you consider graphite, it conducts electricity. Normally non-metals do not conduct electricity, but graphite is conducting. Try to recall, metals, they are also conducting electricity. Here graphite is also conducting electricity. So can we call graphite as metal? No, because if I consider its all properties, most of the properties are similar to non-metal. If I consider graphite's all property, most of the properties are similar to non-metal. That's why it is non-metal. If I consider mercury, most of its properties are similar to metals. That's why it is metal. Okay? I hope now doubt is clear. See, Aditya, that classwork and notes all are available in that Google Drive link. One in WhatsApp, just check that. You will get. Yes, Nishit, very good. So Nishit is saying graphite is a type of carbon. Very good. So carbon is having different form. Like diamond is also carbon. This graphite, it is also carbon. Okay. Very good. So different form. Srishant, why can you come to Hyderabad, that branch? Why I need to go? Huh? Reason you must write, right? Acha, bromine. Why you are writing bromine? Acha. Acha, this Vajrala is asking, who invented 118 elements. First of all, you have written invent word. Here we cannot use that word. Here we have to use discover. There is difference. Invention means you are creating something. You are creating something, and discovery means already it is present in the nature. I am just discovering. Yes, see, this is one species. Difference is clear. Invention means you have to create something new. For example, this smartphone. Nature is not giving this smartphone, right? Here invention word will be there. But if I ask you gold, invention of gold, that is wrong. Because gold is available in nature. We are just identifying and extracting that. So there, discovery, that word will be there, discovery, because it is already there. Okay? So that's why that discovery word you have to mention. And this 118 elements, see, there is no one single human that who discovered all of that. A lot of scientists were there who discovered all of this. For example, Marie Curie, she discovered 2 elements. Okay, then so many elements. There is a it is not just a credit of one scientist. If you just read the history of last 400 years, especially 400 years, whenever you have time, read the history of science, physics or chemistry or math of last 400 years. Then you will be really interested how our whatever we are learning, how we have reached to this state, how scientists thought, how they conducted experiment. Okay, there is no one, we cannot give credit to only one scientist. There are multiple scientists who work day and night. Okay, so these are all the outcomes. We are just simply studying what they discovered. Okay. Acha, now one is asking, why carbon is not in metal? So just now I said, I am giving one example. Again, I am giving the similar example, just you will understand. Total, let's consider you are studying 5 subjects. Okay, out of 5 subjects, 4 subjects, in 4 subjects you are scoring less than 20%, and one subject more than 50%. So normally what I'll say, you are below average students. But if you are scoring 4 subjects very well, more than 80%, 90%, only one subject little less, then I will call you are a good student, very good student, correct? Similarly, if you are scoring all 5 subjects near 50%, near 50% means not towards 0, not towards 100%, you are just in between. So you are a mixture of good and bad, right? Both. So that's why I'll call you metalloid. Metalloid means it is a mixture of metal and non-metal, right? Means mixture means, what do I mean by mixture? Properties. Metalloid, it is having properties of both metal and non-metal. Similarly, we have to focus. If we have carbon, whatever properties it is showing, most of the properties, they are connected to non-metallic property. Correct? That's why it is a non-metal. Only based on properties we are classifying. Correct? Only based on properties. Acha, now I hope this writing part is done, correct? Next, metalloid. Only this, just few informations we have. Metalloids, the elements which show some properties of metals and some other properties of non-metals. See, the same thing, whatever we just discussed. These are also called semi-metals. normally we don't use semi-metal word. Most of the time we use this metalloid only. That is the most accepted form. Okay. No, graphite is not metalloid. So here we have example. Only these: boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and astatine. Only these. How many? 1, 2, 3, 4, 5, 6, 7, and 8. Total 8 elements we have. These are called metalloid. It will be better if you remember this 8 elements name with symbol, because in MCQ question sometimes they will ask you arsenic. It is metal, non-metal, metalloid, noble gas. 4 options are there. So if you know, okay, arsenic, total 8 elements I studied, arsenic is metalloid, so immediately you will click. So these are like information, you have to remember this. Okay, then it will be easy. Okay. So what are these properties? They look like metals, but they are brittle like non-metals. They are neither conductor of electricity like metals nor insulator like non-metal. Means they can conduct very little amount of electricity. So our mobiles, computers, these are all based on which metal? The main working. Without this silicon and germanium, especially this silicon, without this silicon, you cannot produce a single electronic device like mobile, computer. Silicon is so important. That's why Silicon Valley, there is a term. Google in USA, that Google branch, that is called Silicon Valley. So by that way you can understand how much important it is. Silicon, it is very, it is having so many exceptional properties. That's why we can easily, we can use that in multiple way. Acha, someone is writing Lohit, difference between metal and metalloid. See, always remember, metal means metal and non-metal. These two are totally different thing. Metal means it is having metallic properties, like metallic sound. If you rub, you will get some sound. If you visit metro station, I am giving one example. If you visit any metro station, just you are standing, okay, like Madhapur or somewhere else, just you are standing. Metro is not coming, but you are hearing some high frequency from that, lines, from those lines, because somewhere else that metro rail, wheel and that lines, both are made of iron, so that rubbing is happening. So because of that you are getting that sound. Okay, so metallic sound you will get. It will be a good conductor of electricity, heat. Okay, it will try to lose electrons. So many properties. Then bright, it will be very bright in nature, shiny in nature. So these are all metallic property. Non-metallic property means totally opposite. It will not conduct, normally it will not conduct electricity. It can be in solid, liquid, gaseous phase. Okay, it will not shine. Okay, so these are the properties. You will not get any metallic sound in this case. Now metallic property, non-metallic property, these two are fixed. Now whenever we observe these two things, and whenever we observe periodic table, total 118 elements we have. Out of that these 8 elements, whenever we study these 8 elements, they are having some properties like metal, and they are having some properties like non-metal. Try to understand. So these are the 8 elements. They can show some properties like metal. They can also show some properties like non-metal. So that's why we cannot say these are all metals. We cannot say these are all non-metals, because they don't fully follow any one of them. That's why there is a new term called metalloid. So metalloid means, by definition, it means which who will follow both, some properties like metal, some properties like non-metal. That's all. Okay. Achha, now some students are asking like historical question like who this metal name, non-metal name, then metalloid name, element name, all of this. And not only that, you can ask me like this: why German? Why oxygen? O2 means oxygen. This oxygen, who gave that oxygen name? Who gave that nitrogen name? Right? So all this context, it is connected to Latin, that era. More than 200 or 300 years ago, during that time, or also much before time, mostly Greek and Latin, in those two areas, there they were very much advanced in science at that time. So all those words, lot of words will be there which will be coming from their language. Okay, which will be coming from their language. For example, mercury. Okay, mercury. So, the gold, iron, so ferrum, then this type of word, sodium also. So, the origin is connected to that Greek and Latin alphabets. Okay, it is not like one single human gave. Okay, today this will be called as metal. Today I am introducing non-metal. No, it is not a single human's credit. From that aspect, and also we don't have that specific name or specific we can say that proof that only this human is responsible for this. No, it's a multiple scientists contributed to this, and it's a from that only we are adapting all of this. Okay, there is no single credit. Yes, for some elements, for example, if I consider later on element like Einsteinium, it is dedicated to Einstein. Okay, but it is not, that name is not decided by one human. That name is decided by a organization called IUPAC. Okay, so later on you will study all of that. Nowadays, whatever name we are giving, means whatever names in science, whatever new terms are coming, who is giving that? IUPAC. You will study all of this. IUPAC. Okay, International Union of Pure and Applied Chemistry. Actually, in chemistry, only this organization, it is deciding what name we should give, okay, and how to give. So everything regarding that. Acha, writing part is done. If writing part is done, let me know. If writing part is done, let me know. Yes, silicon and germanium. Yes, so this is called semiconductor. Semiconductor. You will study. They are called semiconductor. Mostly, see here. Don't forget this silicon and germanium. These two are very, very important. Silicon and germanium. Okay. Writing part done. I have given lot of time to write this. Okay, let's go to the next. Okay, now this is the fourth one. Rare gases or noble gases. Already we discussed. The elements are found in air in the form of gas in very small amount. See why noble gases are called rare gases? Here we have reason. In atmosphere, we have very, very little amount of these gases. Since they are available at very smaller quantity, that's why rare. Okay, that rare word is connected to this. Okay, since they are available in very small amounts, so that's why they are rare gases. Okay, so first point done. They are called noble gases because they generally do not react chemically with any known element. So these two are very, very important. So example, helium, neon, argon, krypton, xenon, radon. Related to this, I have one question. Do you know the latest element in the periodic table? Which one is the latest element? 1, 1, 18. Do you know the name? Very good. SCH is writing organization. Okay. Nishit, correct. You're on whatever you're writing, correct. Srishant, correct. Yajnarup, no, you have to check that period table. And my suggestion is, since you are at home, in Google, if you write periodic table, and you will get latest one, ACS. You will see this word ACS. Okay, ACS publication. So one periodic table is there. You can download free of cost. Okay, just download that, and if it is possible, take a printout. That is latest one. All 118 elements, their symbols. Okay, a lot of things are mentioned there. So in Google, what you will do? Periodic table, just write periodic table ACS. Okay, you will get one PDF. Just save that or take a printout, and every time you have to follow that one. Okay? Chemistry is nothing. See, by definition, what is chemistry? Chemistry is all about studying elements. Okay, so before studying elements, you must know how many elements are present. Okay, so their name and everything. So that is the alphabets, like alphabets. If you don't know alphabets, you cannot frame sentence, right, or word. Similarly, if you don't know these 118 elements, I'm not asking to remember all of that, but my suggestion is at least 80 elements you have to remember from exam point of view. It may not be required right now. You have 1 year, 2 years time. Since you are in 7, by end of the 8th class, you must recall all 80 or 90 elements. Okay. Now, if you are done, now if you are practicing, recalling all these elements, it will be very good. Acha, MNK. Okay, you have taken print out, and that extra, whatever I am writing, extra thing you are writing, that is okay. But point is, if you are taking print out, so most of the things you are skipping, you are not writing, correct? And it is scientifically proven, if you are not writing something with your own hands, it is very difficult to recall that. For example, let's consider you are just taking print out and writing extra thing only. And your friend, he is writing everything in detail. Whatever is written, he is writing using his own hand. After 10 days, if I ask you and your friend the same question, there is a high chance that your friend will answer and you might have forgotten that. So point is, if you write something, you can easily recall that. Okay, so writing is very, very important. I know, see, technically, if you take, this slide and everything, if you take print out, there is no use of writing. Na? So in that way, you are lost actually. Our purpose is to understand everything clearly, and if exam is there, by default we will get nice marks. That is the byproduct. But understanding all of this, recalling this thing, this is the main purpose, right? So my suggestion is, you must write with your own hands, and if there is any a mistake or you missed some points, yes, you can take help from those. Yes, organization. All of you are writing correct answer, organization. Bindu is smart. Acha. Very good. If you have doubt, please write your doubt. Means slowly you have to recall. Okay, it is not like overnight you have to recall all those at least 80 elements. It is not like that. Slowly you have to recall, because it is just you have to recall now, memory based. So if you practice more, you can easily remember. Okay, yes, Google, from Google you can easily get that. Acha. Next, writing part is done. Are ACS means American Chemical Society. Okay, not ASC, American Chemical Society, ACS publication. They publish a lot of research journals. I have 3 or 4 journals there. Okay. Okay, done. So next point. Lohit is asking, sir, in space there is no oxygen, right? How the sun is burning? See, here, sun is not waiting for oxygen. Inside sun, there is a nuclear reactions are happening. Fusion and fusion, you will study in future. Fission and fusion. Those are the type of nuclear reaction, okay? So hydrogen atoms, they will be colliding and forming H2, helium and hydrogen. So this type of conversions will be there. Nuclear reactions, that is totally different type of reactions. Here only we will be talking about electrons, but there protons, neutrons, everything will be there. Okay, so that is totally different thing. So atomic bomb, hydrogen bomb. Okay, so these are all based on nuclear chemistry, nuclear science. Their electrons, their that burning, whatever you are saying burning, we don't say that one is burning. We will say explosion. Okay, that explosion is depending on those nuclear reactions. Okay, you will study in future. Okay, so this part is done. Next. Now compounds. As a first we studied up to 10-20, right? Just tomorrow I'll start from this. Jagga Bharupu, he's asking, if we hire, means if we go high, towards space, it gets colder, but the sun is getting near to us, it should get, say, deep space, temperature is 0 Kelvin, means minus 273.15 Kelvin. Sorry, degree centigrade. Minus 273.15 degrees centigrade. So it depends on our atmosphere. How? Not only that, from ground, if you go height, first, temperature will be, somewhere temperature will be going down, somewhere it will be going very high. Okay, and if you are leaving this earth atmosphere, temperature will be very, very less. Okay, so it depends that atmosphere, a lot of things are there. Just write this. Tomorrow we will continue from this. Okay, tomorrow we will continue from this slide only. If it is possible, just write now, or tomorrow we will start. Okay, so whatever I discussed till now, is it clear? Put thumbs up or write something in the chat box. Whatever we discussed, is it clear to you? Sign it, thumbs up. Okay, okay, yes. Whatever we discussed, everything is clear to you? Okay, very good. Okay, next class, there we will discuss, we will start from this. Thank you.
Okay, so here I am Dr. Namrata Nagar. I was teaching you about soil. So what we have learned so far: formation of soil, weathering of soil, okay, soil layers, soil features, okay, pH, fertility, soil layers, okay, OAE, BCR, okay, these were the layers of the soil. Okay, here we are going to discuss soil erosion. Okay, yesterday so many doubts were left behind. Okay, many of them were asking percolation. Okay, so many doubts which I faced. Okay, you were asking about contour flowing, you were asking about mitigate, you were asking about percolation, and you were asking about one more thing, I think clay, because clay doesn't let go water, so how can it filter water? Okay, so these were your doubts, these 4 or 5 doubts I'm going to discuss these. Okay, even if you have then any doubt, you can ask again. Okay, this is your contour flowing. Can you see the diagram? Okay, what is contour flowing? Okay, two terms I introduced you yesterday, terracing and contour flowing. Okay, so what is contour flowing? Say this is again, let's say your hill. So when you cut across, okay, this is say your land. Okay, when you cut across, okay, like this, so you are making steps. Okay, and when you go along, so it is contouring. Okay, these lines, these are along the contour. And what we do in terracing, we cut like this across. Okay, we cut this part and we make a step here. Okay, we cut this part and we make a step here like this. Okay, so this is step formation. This is step formation. This is step formation. But what is we are doing in contour flowing? We are going along with the walls. Okay, so this is your contour flowing. You can see here. See, because water is accumulating here. If these contour lines will not there, if these contour lines are not there, what will happen? Water will go straight to down and it will take soil away with it. So this will cause soil erosion. But because we are creating these contour lines, so what is happening? Because of these contour lines, you can say water is accumulating here. And because water is staying in that place, okay, so soil is not going away with water. So this is your terracing and contour flowing. Do you have any doubt in terracing and contour flowing? Blurry, screen is blurry. Okay, I think now terracing and contour flowing you can understand. Soil erosion and soil conservation, we were discussing soil erosion. Soil erosion occurs when the topsoil is removed. Okay, I think this is your slide where we started. Okay, soil erosions occur when the topsoil is removed due to wind, water or human activity. Okay, because of speed wind. Okay, soil can go away with wind because of heavy rainfall or because of heavy flow of water, soil can go away with water. And because of human activity, okay, how human activity can cause soil erosion, you know, because we are deforesting. Okay, we are cutting the trees. Okay, because of tree there is less soil erosion. How? Because the tree, where tree grows, it protects that much area or area around it, because whenever water rainfall occurs, okay, the impact will be less powerful or it is less impact on soil, so it can prevent soil erosion. But we are cutting trees, so somehow we are causing soil erosion also. So human activity, wind and water. Loss of soil, it can result in loss of soil fertility. Of course, if topsoil is removed, of course fertility is gone. Desertification, cutting trees and habitat destruction. Okay, habitat destruction, because there are so many soil organisms is there. They improve soil fertility. If topsoil is not there, microorganism will also gone away with soil. So this is your, you can see clearly these lines. Okay, because top layer is removed. Soil conservation technique include contour flowing, terracing, agroforestry and cover cropping. So I told you contour flowing, okay, these let's say your land area. So you are flowing along the area, okay. And what is in terracing? You are cutting the land area and forms terrace, forms steps, okay. So you are forming steps by cutting that land area, okay. You are cutting, let's say this, I am cutting like this. So this is like this, a area is formed here, a step is formed here. But we are not doing this in contour forming. Contour forming is just aligning the surface, okay, flowing along the surface. to reduce water runoff and prevent soil erosion. Creating step platforms on steep land to reduce water runoff and erosion. Okay, both are the same thing. Both are using for reduce water runoff. Okay, water flow impact, lower the water flow impact. But what is the difference? In contour flowing, we are going alongside the surface, and in terracing we are going across the surface. We are cutting the surface and creating steps there. Third is agroforestry. Again, planting trees along with crops to stabilize the soil, reduce erosion and improve fertility. Okay, so this is your agroforestry. If you are growing in a farmland, there are so many crops. So what we are doing here, we are growing trees in between. Okay, I told you the diagram here. See, this is your farmland and there are so many trees in this farmland. So what will tree does? Okay, it prevents soil erosion. Cover cropping. Okay, you can take an example of grassland, because grass covers like a sheet, so it will lessen the effect of rainfall. Do you have any doubt in this slide? No doubt? Yes, sometimes both are done, sometimes only contour flowing is done, sometimes only terracing is done, sometimes both can be done. Okay, please don't waste your time on unnecessary messages. Okay. Someone is writing. Okay, so if you have any doubt in contour flowing, terracing, agroforestry, cover cropping, okay, done. Soil is not only vital for plant growth but also play a crucial role in broader ecosystem. Okay, carbon sequestration. Okay, this is the term many students were asking yesterday. What is sequestration? Sequestration is removal. Okay. Okay, sequestration is removal. Temperature down. Sequestration is removal of carbon. How carbon is removing from environment? How it is helping environment? You know, soil is helping environment by reducing the carbon level. You know why we want decreased carbon level? Why more carbon is harmful? It causes greenhouse effect. You know, it can trap heat. Greenhouse effect or global warming. You do know something about global warming? Okay, I will tell you. Soil is not only vital for plant growth but also plays a crucial role in the broader ecosystem. How? Carbon sequestration. Soil acts as carbon sink, storing carbon from the atmosphere and helping mitigate climate change, because whatever carbon is present in environment, soil can take them, soil can store them. How soil can take them? You know, plant is having organic matter, means carbon. Animals, they are having organic matter, means carbon. So whenever they are dying, okay, their carbon material or their carbon matter comes into the soil. So somehow soil is sink for carbon. Okay, whatever carbon is coming, soil can store them. So soil is a carbon sink. It is storing carbon from the atmosphere and helping mitigate climate change. Okay, mitigate climate change means it is helpful in climate change. Climate change, whatever climate change are happening out there. What climate change? CO2 level is rising. We don't want that. Okay, so what soil is doing here? Soil is keeping that carbon, okay, with it. So there is somehow it is helping in lessening the carbon level. Okay, so CO2 level will be less. So somehow it is helping mitigate climate change, means whatever bad climate change is happening, it is making it less painful or less harmful. Okay, whatever because of CO2, see, we having a bad effect on environment because of CO2. So if soil is somehow conserving or storing CO2 or carbon, Okay, so we can say that it is helping environment. Water filtration. Okay, so one doubt was your sequestration, it is cleared. One was contour flowing and terracing, I already discussed. Carbon sequestration. Sequestration means removal. Mitigate climate change means climate change, make the climate change less harmful. So this is your mitigation, making them less harmful. Water filtration. Okay, here comes many so common doubt many students were asking, that clay particles will not let water go in between or through them. So how they can filter water? See, someone was saying, ma'am, please don't use yellow color. So what color I should use? Only yellow is most visible in the screen. Okay, in compared to black or blue or red, any color. Okay, I think I should take let's black color. Okay, see, let's say these are your soil level. Can you see? Can you see these lines on the screen? Okay, so let's say these are your soil particles. This is your top soil. Can say A layer. Okay, this is your O layer. Okay, this is your B layer. So what we are doing, that when water will come, what will happen when, let's say we have dirty water. What dirty water means, we have pebbles inside it, we have dust, and we have toxic particles inside it. So what is happening here, when this water go through these layers, when this water go through these layers, it get filtered. You know, groundwater is so pure because it get filtered through the soil layers. Now your doubt was that, ma'am, let's say here the clay particles. I am making clay particles here. Can you see the clay particles? Is it visible to you? Is it visible? Okay. So let's say this is your, these are your clay particles. So I am not saying that this whole layer is filled with clay particles. Clay particles, sand particles, silt particles, they all are mixed. Okay, it is not like only clay particles layer is there, only sand particles is there. So you are thinking like clay particles layer is there and water cannot go through it. Please don't think it like that. Okay, clay, they are scattered now, they are mixed. We have silt particles, we have sand particles, we have clay particles. So every particle is doing their job. Okay, sand particles is filtering. What sand particles is doing? Let's say this is your sieve. You do sieve, right? So whatever the pores are forming here, okay, because of sand particles, okay, larger particles cannot go through these pores. So sand particles are functioning like that. Okay, they are acting like filtration because they remove the larger particles. They act as larger sieve. You know sieve? Let me draw a sieve. See, this is, let's say, your sieve. Okay, so see, this is smaller sieve. So the particles which is larger than this pore, they cannot go through this layer. So sand particles are doing like that. Okay, they are act like a sieve. They act like a filter. So larger particles, because sand particles are already large. So the particles larger than sand particles, they cannot go through between the sand particles. So they are removing the larger particles, larger impurities. Okay, what is clay particle doing? Clay particles are holding impurities. There are so many toxic substance or heavy metals, clay particles stick with it. Okay, because it stick with it, the water which is left behind, it can go through the other particles. Okay, clay particles is providing stickiness. Okay, so some harmful substances will stick to clay particles, but it is not forming a complete layer which block the water which is coming from upward side. Okay, getting my point? So this is your carbon sequestration done. Soil filters and clean water as it percolates through removing pollutants and improving water quality. So what we are doing, okay, removing larger particles, removing dust particles, removing toxic substances. We have soil microbes which can degrade toxic substances also. So somehow we are purifying water and improving water quality. That's why groundwater is so pure, okay. Soil supports a variety of life forms contributing to overall biodiversity and ecosystem health. Okay, so soil supports a variety of life forms contributing to overall biodiversity and ecosystem. Okay, what microbe soil is having? Fungi, bacteria, earthworm, many kind of insects, okay, larvae, flies, okay, flies larvae, not flies, okay. So there are so many kind of organism is present in soil. So this is all about 2 slides we have completed, right? Okay, one is soil erosion. Okay, we have learned terracing, contour flowing, agroforestry, cover cropping, carbon sequestration, water filtration. Do you have any doubt in this? Please ask. If you have any doubt in this, please ask. Percolation, okay. Okay, just percolation is only word is left behind. Okay, that adds. Do you still have that doubt that clay particles will not let go water? Then how it can filter water? Now you don't have that doubt, right? Let me tell you percolation. See, percolation. Okay, let's say this is your soil level, okay, and these are the particles. So when water can go through these layers, through these particles, water can move it. This is called percolation. Okay. Now you can ask, ma'am, what is the leaching? Okay, when it will go so down, more deeper, if it can go more deeper, it is leaching. Okay, this is percolation. Okay, for local area we call it percolation. Okay, and if because of rainfall it goes into the deeper and deeper layer, it is leaching. Okay, clear? Now I think if anything is carbon sequestration, biodiversity. Okay, carbon sequestration and biodiversity. Okay, what is carbon sequestration? See, this is your soil level. Okay, this is your plant. What plant is doing? Photosynthesis. So they are taking CO2. Okay, so CO2, environment CO2 is taken by plant. What they are doing by this? They are forming carbohydrate, or you can say glucose. Okay, so this is carbon source again, and how it is formed? Because of CO2. What will happen when this plant will die or the leaf will come into the soil? Let's say if this plant is not dying, there are so many leaves which are coming to the ground. Okay, so what will happen? Whatever the carbon source, it is coming into the soil. Okay, whatever, let's say animal is dying here. So whatever carbon source is inside it, it is coming into the soil. So it's storing carbon. Okay, so it is this is soil. Okay, this line is showing soil level. Okay, so below this line is soil. Now you get it. It is carbon sequestration. Carbon sequestration means removal of carbon. From where we are removing carbon? From environment. And how it is helping environment? Because if this carbon will remain, okay, somehow this is coming from CO2. Okay, this animal is depend on plant. So somehow we are decreasing this CO2 level because plant are taking that CO2. So this CO2 level in environment will be decreased, and this is what we want. This CO2, if CO2 will remain, let's say if CO2 will increase in environment, what it will do? It will trap heat. Let's imagine earth like a room. This is our earth, okay? So what is happening? This is where we living. Okay, in this part, suppose we are living here. So what is happening? Whatever CO2 is there, the more the CO2 we are having in our environment, whatever the heat, whatever the sunlight is coming, okay, it is getting trapped here. Okay, I am changing the color to yellow. Okay, whatever the sunlight is coming, it is getting trapped here. This CO2 particle will trap this heat into our environment, and this will cause global warming. So because plant is somehow helping in decreasing this CO2. Okay, and this carbon is stored somehow in soil. So indirectly or directly, we are helping, or soil is helping to mitigate climate changes. Got it now? No doubt except for percolation. Okay, Bindu. Percolation, when water goes through between particles, it is percolation. And when water will goes down to the layer, down to the deeper layers, it is leaching. Bindu Shaurya, please thumbs up if you understand percolation. Bindu. Okay. Okay, this is the percolation. Okay, water is going through between the particles. This is called percolation. Okay, and there are so many layers I am doing. Okay, this is leaching. If the minerals goes down to the deeper layer, it is leaching. Okay, percolation is this movement of water through these particles. This is called percolation. Mahita, yes, I can see your chat. Is leaching good or bad? Leaching is somehow bad because the minerals which we are going down to the layer because of heavy rainfall, they have no use for plants. So sometimes they go so deep that they are unavailable for plants. Ma'am, can you show previous slides from which you started yesterday? Ma'am, who named soil as soil? Okay, soil came from solemn. The first day I told you soil word came from solemn. From here I started Kaustubh. Okay, these four topics, these four definitions we have covered: contour flowing, terracing, agroforestry, and cover cropping. Adya, what you are asking, please tell me. Adya, please ask if you have any doubt. Tanmay Reddy, you don't need to write, okay? You all have this slide with you, okay? You already shared or provided a link, okay? When you will open this link, you will get these PDF and you can download them. So you don't need to write it. If you are thinking that some point is written here, and if you think that I am explaining something which is not written here, you can write it. Swastika, cover cropping, biodiversity. Okay, cover cropping in biodiversity. Cover cropping. Okay, what is cover cropping? Let's say we have naked soil. So what will happen? This soil can go away with wind, this soil can go away with water. See, if the grass is growing, if grass carpet is growing over this soil, what will happen? This soil will stay here. This soil is attached here, okay? This will not go away with wind or water. So this is your cover cropping. You can grow grass over the farmlands. So the soil erosion can be prevented. Now got it? I think it's over our doubt session. Yes, I can see all your messages. Don't ask me, can you see my message? Please ask doubt. Okay. I think we should proceed further. Okay, next slide, we will have doubt session for the next slide. Biodiversity, someone asked, what is biodiversity? See, bio means life, living beings. They can be microbes, they can be plant, they can be animals. Diversity means variation. What variety we have animals, what variety we have in plants, what variety we have in microbes. So this is our biodiversity. Now comes to soil biodiversity. Okay, there are so many kind of organism which is living in soil. Insects, okay, larvae, pupa, earthworm, microbes, fungi, bacteria. There are so many microorganisms which are living in soil. So this is the biodiversity of soil, because it is providing, or soil is shelter for so many organisms. So soil supports a variety of life forms contributing to overall biodiversity. Okay, if let's say remove the soil, so what will happen? Whatever the organism which is living inside the soil, they will extinct. Okay, they will disappear or they will die. They cannot live or they cannot survive. So what will happen? The species diversity, the number of insect or the number of bacteria or the number of fungi we are having, they will decrease in count. So it will be less biodiversity. Okay, whatever soil microbes we are having, they will be lost from ecosystem. So this is how soil maintains biodiversity. Carbon sequestration. Okay, this is the last time I am telling you carbon sequestration. Okay, please listen carefully. Sequestration means removal. Plants are removing carbon from environment, because this carbon, if this carbon will remain in environment, it will cause global warming. It will it will rise the temperature of our earth environment. Our earth environment. Okay, so plant is taking CO2 and this carbon source is coming into the soil somehow. So directly and indirectly, soil is helping in environment to mitigate the environment change, to make the environment change less harmful. Adsorb and absorb. Okay. Okay, when something stick to only surface, it is adsorption, and when something goes inside that body, it is absorption. Okay, so when it is stick to only surface part, it is adsorption. Okay, let's say charcoal. What charcoal does, it will attract impurity. Okay, whenever you charcoal block, if you are having a charcoal block, okay, you must have seen the charcoal face wash. What charcoal face wash does, when we apply it in our face, it will take away all the impurity. I am not promoting charcoal face wash, I am just saying about charcoal. So what charcoal does, it will attract impurities. Okay, so if you have a charcoal block and if you keep it, so there are so many impurities, it will stick to that charcoal block. So if this stickiness is over the surface only, okay, this absorption, this is not absorption, this is adsorption. Okay, something is stick on the surface only. I think I now comes to soil pollution. Soil pollution is the contamination Okay, soil pollution is the contamination of the soil with harmful substances that can degrade its quality, reduce its fertility, and pose a threat to human, plant, and animal health. This contamination results from various human activities. Let's say how soil pollution is taking place. In your term, please let me know how soil pollution is happening in our environment, how soil pollution is happening. Whatever the reason of soil pollution. Please remove this now. This part, this taskbar is hiding behind it. Eraser is not working. Okay, so whatever, let's just discuss about soil pollution. Okay, we are seeing these days we are using so many pesticides. Okay, what was happening in earlier days, whatever crops are growing in farmlands, we are doing just cow manure. Okay, we say it gobar. Okay, so we are just using cow manure to growing our crops or to improve the soil fertility. These days we are we are using so many fertilizers. Okay, now you can say, ma'am, fertilizers are useful. How can they create soil erosion or how can they cause soil erosion? Okay, whatever the fertilizers we are using, for the time being or temporarily, we can say they are useful for our crops. Okay, they are useful for production. Okay, they are useful for yield increment. But what is happening here? Because these fertilizers, they are accumulating in soil. Okay, so what happens here? Soil pollution is the contamination of the soil with harmful substances. We are spraying pesticide. Okay, pesticide in crops. We are spraying fertilizers. Okay, artificial fertilizers, nitrogen and phosphorus compound. We are spraying on our crops. Okay, so many pesticide, insecticide, fungicide. Okay, so many type of chemicals we are spraying over our crops. So, however, they are increasing our production, but what is happening? Whatever chemical we are using, it is coming somehow into the soil and it is accumulating into the soil. So, this is how soil pollution works. Okay, contamination of the soil with harmful substances that can degrade its quality. Because of that, soil quality will degrade or reduce. Its fertility is reduced and is pose a threat to human. Okay, and animal health. Okay, this is also harmful. Animals means including humans also. It is also harmful for humans. But for the time being or temporarily, because it is increasing production, we are using chemicals. This contamination results from various human activities such as industrial processes, agriculture, waste disposal and urbanization. What is urbanization? We are making concrete jungles, we are cutting trees and we are making buildings. We are building, so many industries are growing because of agriculture. Okay, see, normal forest is there, so many kind of biodiversity is there, so many kind of plants are there. But what we are doing for farming, we are because of farming, even farming we are also growing crops there, but it is not so beneficial for ecosystem like trees. Okay, somehow let's say you say that you are a nature lover and you are growing plants in your home. So what the plants are doing? Okay, if you actually like the nature and if you actually want to help to the nature, what you should do? You should grow plants or should grow trees. Okay, and it is not like you are just celebrating environment day, you are just growing a small plant, or it's your birthday and you have done a good thing that I am growing a plant today. But growing is not just enough, you have to take care of that plant so it can grow into a tree. Okay, even 1, 2, 3 or 4, 5 trees you can grow. It is very beneficial to the ecosystem or to the environment. It is not like you are growing some 4 or 5 shade loving plants inside your home for decoration. That is not going to help nature and that is not going to help ecosystem. Same way, because we are doing farming, okay, so because to make farmlands also, we have to create a equal surface and now put a soil over this surface and now farming can started over this land. So what is happening here? We have started farming over this land, but to make this land as a farmland, we have to cut so many trees. Okay, so for agriculture also we are disturbing nature. For industrial processes also we so many industries also, and for so many buildings. Okay, urbanization, because so many buildings are there. Okay, if you have seen around, everywhere construction is going on. Okay, have you seen some place there construction is not happening? Everywhere is construction is going on. So what is happening? We are making concrete jungle. Okay, concrete forest, you can say. Whatever forest we are having, we are removing, we are cutting trees and we are making concrete jungles. So this is how we are polluting our soil. So this is called industrial processes, agriculture, waste disposal. Okay, waste, there are so many kind of waste. I cannot describe each and every kind of waste. Okay, house waste. Okay, these days cloth waste also is there. Okay, earlier we used to wear 1 or 2 clothes per year. Nowadays we change per month. Okay, today I am wearing something, tomorrow I am wearing something else, day after tomorrow I am wearing something else. Okay, so this is how we are causing harm to our soil. So this is directly or indirectly soil pollution. See, I think you cannot see this image. Can you see this image? There is a garbage over here, okay, and one person is collecting something from here. And these are the points of soil pollution. Okay, I will describe. I think I cannot erase this. Okay, so in this flow chart, in this flow diagram, you can see there are cause of soil pollution. What can cause the soil pollution? Okay, even if you cannot see this, please listen carefully. Okay, because I think for some reasons eraser is not working, so I cannot erase this. So I am saying this loudly. Please listen carefully. Please don't text. Okay, just focus here. Use of pesticides. Okay, because of using pesticides, these pesticides are somehow harmful chemicals. At the end they are coming into the soil. So this is the one reason of soil pollution. Next, amendment with soil waste, solid waste. Okay, sometimes we use manure. Okay, we are using so many things as a manure, so we mix something with it. So amendment with solid waste, if we are mixing something with our manure, so what is happening? There are so many plastic or so many other things mixed with that manure and it comes ultimately into the soil. So amendment means additional mix. If we are mixing something with our solid waste, okay, it can be plastic or it can be something else, somehow it is coming into the soil. Livestock wastage, irrigation with poor quality water. You know irrigation? I think you know irrigation. Okay, irrigation with poor quality water. Okay, whatever the dirty water, we call it sewage. Okay, from cities, whatever dirty water is collecting from all over the city. Have you seen that whatever water we are using, whatever water is going into our drain, where it is going? Have you thought about it? It is called sewage. Okay, and whatever is government doing, we do sewage treatment. Okay, whatever the left behind water or whatever the dirty water is coming from cities, okay, it is called sewage. SEEWAGE, sewage. Okay, so whatever the water, the dirty water be collecting from cities, it is called sewage. So sometimes what is happening here, this sewage is directly drained into the rivers. Okay, rivers, they were having pure water, or you can say less pollutant water earlier. But whatever is collecting from cities, it is mixing with this water. We getting mixed it with this river water. So we make it more pollute. Okay. So sewage treatment. Sewage treatment means whatever the water is coming, dirty water is coming, it should be treated once. It should be treated like primary treatment, secondary treatment, tertiary treatment. There are different kind of treatment which should be done to sewage water, and then it should be drained into river water. But in some parts there is no sewage treatment. Okay, there is no sewage treatment, no primary, secondary, tertiary treatment, nothing. Okay, there are so many steps in treatment. Primary treatment, we are just removing particles. Okay, in secondary treatment we are doing degradation, microbes are doing degradation, so making it less pollutant. Okay, so if there is no sewage treatment, whatever happening, whatever is inside this sewage, this will goes directly into the river and make that river more polluted. So this is, and if we irrigate with this water, okay, if we are using this water in our crops, in our farmlands to grow our crops, what will happen? Okay, all the impurities will come into the soil. Okay, and that somehow, because plant are absorbing from that soil, so that will goes into that plant, and we are eating that plant, so that comes into inside our body. Over fertilization, excessive use of fertilizers, nitrogen and phosphorus, it will make soil less fertile over the time. Irrigation with untreated wastewater. Okay, it is the same point, irrigation with poor quality water or irrigation with untreated wastewater. Untreated wastewater, I told you that wastewater is called sewage. The term for wastewater, it is called sewage, and it is not treated. If it is not treated and it is used as it is, or it is mixed with rivers as it is without treatment, so these are the causes of soil pollution. Okay, screen is blur.
Here's some info about soil contamination.
Screen is blur. Students are saying screen is blur. Okay. You can see it, there are so equation what can cause the soil pollution. Even if you cannot see this, please. Okay. Okay, do you have any doubt in this? What are the causes of soil pollution? Even if screen is blurred, please listen carefully. If you have any doubt, what is charcoal? Hello, am I audible? Okay. So I'm saying that please don't write unnecessary text. It will waste your energy. Okay. Please write or ask only doubts. Screen blur, error code 1011. Thank you so much for telling me the error code. Okay, I think so many students are waiting for and saying time up, time up, time up. Okay, we will have discussion tomorrow again. Okay, I think this is the over, class is over, okay.